Today I begin with the theorem, which is also called as basic proportionality theorem or Thales theorem. One of my subscriber has requested for the explanation of the proof of this theorem. Now the theorem states that if a line is parallel to a side of a triangle, now here you have a triangle ABC, there is line L which is parallel to one of the side of the triangle, that is BC. So if a line parallel to a side of a triangle intersects, this line is intersecting the remaining sides in distinct points P and Q, then this line will divide the sides, these two sides, in the same ratio. Ratio means AP upon PB should be equal to AQ upon QC. I hope you understood the statement. The statement is that if you draw a line for a triangle such that this line is parallel to one side of the triangle and it intersects the other two sides in distinct point, then this line, then this line divides the remaining two sides of the triangle in the same ratio, that is AP upon PB is equal to AQ upon QC. Now for that purpose, what we do is we join this BQ and we join this PC. Now remember children, there is a property which you should remember or you should understand, that if we have two triangles, here we have triangle AQP, and there is another triangle BQP, AQP and BQP. Now these two triangles have a common vertex, and if you have a look at their bases, if for triangle AQP the base is AP, and for the triangle BQP the base is BP. Both the bases are on the same line. We say that the bases are collinear. So remember, if two triangles have a common vertex and their bases are collinear, then their heights are equal. So this is a property you should keep in mind. We begin as, in the proof, you will say join PC and BQ. Fine. Now triangles AQP and BQP have a common vertex. Common vertex Q, and their bases, which are the bases AP and BP, are collinear. Collinear means on the same line. So triangles which have a common vertex and their bases are collinear have their heights equal. Now remember, this is not the height. Please do not get confused with respect to this PQ. PQ is not a height. If you construct the altitude for this triangle, it will be somewhere here. This will be the height. Similarly, this triangle becomes an obtuse angle triangle, so its height will be the same. So remember, do not get confused with PQ. PQ is not the height. If you write PQ as the height, the answer will be wrong. Marks will be deducted. So therefore, now we have studied one property. If two triangles have similar height, collinear heights, if their heights are equal, then their areas will be proportional to their corresponding bases. So area of triangle AQP upon area of triangle BQP will be equal to what? Will be equal to the bases, that is AP upon PB, since heights are equal. This is the reason. This is a property we have studied in the beginning of the chapter, that if two triangles have equal heights, then their areas will be proportional to their corresponding bases. So this is your equation number 1. Now similarly, we go for these two triangles. Triangle APQ and triangle CPQ. I hope you can make it out. APQ and CPQ both have a common vertex P. their bases AQ and QC are collinear. So again their heights will be equal. Now we are not going to write these things again. We will write similarly. Similarly, area of triangle. Which triangle? Area of triangle APQ and CPQ. Area of triangle APQ upon area of triangle CPQ will be equal to what? The bases are AQ and QC. Okay, reason is the same reason. Heights are equal. Now as such, again come to the figure. If you look at this figure, APQ or AQP is the same triangle. So the numerator is the same here, right? Let us consider the denominators now. Triangle BQP and triangle CPQ. This is your triangle BQP and this is your triangle CPQ. Both the triangles, see, BPQ and CPQ, they have a common base PQ. Fine. And line L is parallel to BC, that is given to us. So if two triangles are lying between parallel lines, their heights will be equal. Getting that? So triangle BQP and triangle PQC, they are lying between parallel sides, so their heights, here will be the height for this triangle, and from here for this triangle the height will be this one. Getting that? So the heights are equal, base is common, so their areas will be equal. If two triangles have a common base and their heights are equal, then their areas will be equal. Okay, so we write this also. Triangle BQP and triangle CPQ have a common base PQ, and their heights are equal. Why? Because they are lying between parallel lines PQ and BC, and their heights are equal because they lie between parallel lines PQ and BC. Therefore, area of triangle BQP will be equal to area of triangle CPQ, since triangles with equal base and equal height. Triangles with equal base and equal height. So now this is your equation 3. Now have a look at your equation 1 and 2. The numerator is the same. We have shown that the denominator is also the same. That means the left hand side of these two equations is the same. If the left hand side is equal, naturally the right hand side will be equal. Fine. I hope you got this. See, the numerator is the same. APQ, AQP, AQP. Okay. The denominator triangle BQP and CPQ, we have shown that they are equal. So that means the left hand side of these two equations is the same. If the left hand side is same, naturally the right hand side will also be equal. So we write from 1, 2 and 3 equations. What do we get? AP upon PB is equal to AQ upon QC. This is what you had to prove. Have a look here. This is what you had to prove, and we got the result. I hope, Shabnam, you understood what you wanted to know. Thank you.